Hello there and welcome to the Building Block. In the last video, someone pointed out that we hadn't covered the polar form of complex numbers, and they were absolutely right. Well, this form is only another way to represent complex numbers. Up to now, we've been working with rectangular coordinates. That means using a real part along the x-axis and an imaginary part along the y-axis. But we can represent the same number using a polar form, and it is actually very useful in certain contexts. Let's take the complex number 3 plus 2i. To convert this to polar form, we need two things. First, the magnitude, also called the modulus or r, that's the absolute value of the complex numbers. It is calculated as the square root of the sum of the squares of the real and imaginary parts. Here we do the square root of 9 plus 4, which is approximately equal to 3.61. Next, we need the angle. This is the angle that the complex number makes with the real axis. We calculate it using the arctangent of the imaginary part divided by the real part. So that's arctangent of 2 divided by 3, which is approximately equal to 33.69 degrees. Now, since complex numbers are often used with radians, we'll convert that angle by multiplying by pi and dividing by 180. That's approximately equal to 0.588 radians. So the polar form of our complex numbers is 3.61 times e to the power of 0.588i. That's it. Now, what if you're given a complex number in polar form and asked to find the rectangular coordinates? Well, no problem, you know the radius and the angle. Just use a equals r times the cosine of the angle and b equals r times the sine of the angle. Of course, this won't be exactly 3 and 2 because we're rounding decimals, but the values will be very close. And just like that, we've completed our final example in the complex numbers series. Thank you so much for being part of this journey. As always, thank you for watching the Building Block. Catch you next time.